Synchronous satellite is a satellite that always stays above the same location on the Earth or some celestial object. The mass of the Earth is 6 times 10 to the 24th. What is the radius of the orbit of a geosynchronous satellite around the Earth?
A geosynchronous satellite would mean it stayed at the same altitude, which means, like, from this force diagram, the force of gravity would have to cancel out with the centrifugal force. The equation for force of gravity is the gravity constant times the mass of the Earth times the mass of the satellite over the radius squared. The centrifugal force equation is mass of the satellite times omega squared, which is the centrifugal acceleration times radius. So from the geosynchronous definition, FC has to equal FG, and as they cancel out right here to keep at the same spot above the Earth. The gravity constant is 6.67 times 10 to the negative 11th, which is constant. Mass of the Earth was given in the question, which is 6 times 10 to the 24th kilograms. Omega is also kind of given from the question because it stays at the same spot above the Earth, which means it orbits once each day, which means it rotates at 2 pi per day. So you have to convert that days into seconds, which equals 2 pi over 86,400 seconds, radians per second.
As stated above, the force of gravity is equal to the centripetal force. And since the mass of the satellite is on both sides of the equation, they're going to eventually cancel out, which is going to end up with the gravitational constant times the mass of the Earth over the radius squared equal to omega squared times the radius. And then you are going to multiply radius squared over to the other side and then divide omega squared, which is going to lead you to this next equation. We were left with the equation gravitational constant times the mass of the Earth divided by omega squared equals the radius cubed. And then we'll plug in all of the numbers that we previously got. Which will be r equals the cube root of 6.67 times 10 to the negative 11th times 6 times 10 to the 24th divided by 2 pi divided by 86,400 squared. And that will give us a radius of 42,297,523.87 meters.